13.6 Directional Derivatives and Gradient, Part 1. Let Z be the surface shown and assume the hiker is at the point AB, f of AB. The hiker would like to travel on the surface in the direction of the unit vector u. Let S be the horizontal distance traveled. Then the curve describing his walk is a function of S. The change in elevation with respect to the horizontal distance, therefore, is a derivative with respect to S. Elevation is a function of x and y, which in turn are now functions of S. Using the chain rule and evaluating at AB, we get this expression, which can be written as a dot product. The dot product is called the directional derivative of f at the point AB in the direction of u, and gives the rate of change of elevation as the hiker travels in the direction of u at the moment the hiker is at the location AB, f of AB. Find the directional derivative of f at the point 3, 2 in the direction of these vectors. Set up the directional derivative for each vector. Next, find f partial x and f partial y. Evaluate the partials at 3, 2, and put these values in for directional derivatives. The final step is to find the dot product. Depending on which direction we travel, the rate of change of elevation is different. Moving in the direction of u, the rate of change is about 2.5 units up for every unit along u. Moving in the direction of v, the rate of change is about 1 unit down for every unit along v. The gradient of f is the vector f partial x, f partial y. The directional derivative of f at AB in the direction of u is the dot product of the gradient of f evaluated at AB with the unit vector u. Find the gradient of f and the gradient of f evaluated at 3, 2. First, let's find the gradient of f. F partial x, f partial y is given here. Next, evaluate at 3, 2. And check your work. Gradient, remember, is a vector. Use gradients to compute the directional derivative of f at 3, -1 in the direction of 3, 4. Big warning here. Directional derivatives are built on the idea of the direction being a unit vector, and the vector 3, 4 does not have length 1. Before moving forward, create a unit vector that points in the direction of the vector 3, 4. U is a unit vector in the direction of 3, 4. Set up the directional derivative. Find the gradient of f and evaluate it at 3, -1. The gradient of f, and now evaluate it at 3, -1. Put our result into the directional derivative and find the dot product. And simplify. And we get -39/50.